Okay, so did you make progress with this assignment?
Yeah.
Right, so the idea was to complete that thing that I mentioned at the end, which is to define nearest point. So a couple of things which I had myself not paid attention to, which is that although you want to ignore yourself, there might be another point at the same distance. So you just can't check distance 0 as a criterion. You should check that something is not yourself. Okay, so that
So the interesting point is that points with the same coordinates are different objects.
yeah, correct. So this was my solution, right? So we have the distance function, and initially, now because we don't know what the distance is, we can't set a minimum, right? I mean, you could, if you knew something about distances, you could set at the minimum distances, but you want infinity basically, right? So you said there is no minimum point. So in particular, if you don't find any point other than yourself, you'll return none. Now you go through all the points. Now this is something which I'll do today, but this, so I'm not checking whether P is equal to self, but P is self, and I'll explain the difference in a minute. But this is more or less saying, is P the same object as the object self?
But I checked it out when we construct 2 points P and Q with the same coordinates. They are not equal.
Correct. Yeah, they should not be, but I'm saying that this is a safer check in some sense, because I don't know, it depends on the programming language in some sense what is equal to. So sometimes, for example, for lists which are not the same thing, but lists, for instance, if the contents are the same, they are equal to, but two lists with the same contents but which are different lists will not be is.
But for a base class probably.
Yeah, so I don't know.
And
so
what's the difference between is underscore self and is space self?
No, the underscore is some Emacs thing.
Oh.
It's just a cursor. Okay, so if P is self, then this continue is a Python construct. It's there in other languages also, which says go to the next iteration of the loop, don't do anything more. So basically skip this point. The other option is break, which is to come out, which is not a good thing to do. Right? So if P is not self, then you continue. So you first find the distance to P because it's not yourself. Now there are two cases. One is a boundary condition, and fortunately it works that you can do both at the same time. If you have never set a distance before, then you must set this to be the first non-trivial point you see is at the minimum distance. So that means that the current distance is negative, because the only way the current distance can be negative is if you have never set it before. So either the current distance is negative or you have found something which is smaller than the current distance. Now it cannot be at the beginning because you can't find a negative distance, right? In either case you update the min point to be the point you just found and you find the distance. Now the reason you need the distance is because in order to compare more points you need to check the distance again, right? So you just go through all the points, and after the first iteration, so the first iteration, the first non-trivial point will be set by this. After that, any update will happen because of this, and then at the end of it, you either have found a point, or if there was only one point, because there's at least one point because you called it as P dot something, then you should get that point. Okay, and as I had mentioned in the text, I'm not very fussy about what happens if there are multiple points at the same distance. You can report. In this particular one, would report the first one in that list. Okay. And if I change that to less than equal to, it will report the last one in the list, because every time it sees something which is equal to or less, it will update. Right now, unless it is strictly less than, it will not update. So if there is a second point at the same minimum distance, it will ignore it. Right. So if I change this to equal to, then I will get the last point in the list which is at the minimum distance. If I just keep it as less than, it will be the first point, but that's not important in this context. Right. So there's nothing very difficult about this. I'm not declaring it in some sense, but I know that this all points, okay, if you go back to the top, all points is appended with self whenever point is created. So all points is known to be a list of points. It's not a list of distances. So all points was created when the class is created. And when each point is added, all points is appended with self, where self is a point. So therefore all points is like a list or an array of points. right? So when I get an element, when I say for p in all points, then I go through each thing in point in that array, and that each thing happens to be a point, so I can use all the point functions on it, right? So it's kind of, because you don't have any declarations, you have to track through the execution of the code to find out what is the value.
Yeah. So there, instead of self,
Yeah.
I just wrote point self and self point.
Where? In
The like after being
yeah.
to all points.
Yeah.
In unit.
Yeah. You wrote append.
So, I wrote after point self and self point.
Point?
Self.x.
Self.x. Okay.
Point of self.x self.point.
Okay. Yeah.
So what happened is that it took showed a runtime error.
That's a recursive call. I mean, it's a.
Yeah. See, that will happen is that so when you say point, when you try to construct, that will try to construct a new point, which in turn will try to construct a new point, which in turn will try to construct a new point. So every time you call point, it will call init. So you will get this recursion, some stack overflow or memory problem. So that's because every time you create a point, it is calling init, which is forcing it to create one more point, which is calling init, and so on. So that's problem. In some languages, there are ways to say create this point, but don't call init. But I forget. But not in Python.
I thought the whole point of init was.
Yeah, but I think to avoid this, if you don't want to.
Oh.
But I mean, you would normally not do this, so it's not worth. Yeah, so I tried to do this clever thing last time, but this doesn't work because there could be 2 points which are at distance 0. So I was trying to do it in one line using this functional programming style of sorting the points by distance and then taking the second value, right? Because I mean, last time I.
Oh no, yeah.
But this won't work if there is another point at distance 0. Right? You'll have to find the first.
No, but you could first filter out that first point.
Yeah, so this as it is, it won't work. I'm saying you have to knock off all the point. When you say p in point, you have to knock off the self, and then it will take the first.
2 steps. I mean, inside that I did a filter.
Yeah, correct.
But this is more efficient because you're not sorting. You're just.
Yeah, exactly. So in order to find the minimum, you don't need to sort. Right? So minimum or maximum you can do in one scan. Whereas sorting will take you n log n. So
there's no thing for lists which finds the element of the list on which some function is minimized.
I don't know if there's a built-in that does that. Yeah, I'm not aware of that, but you can easily write a one-line
So
thing.
you have a list. So there's something called sort using key.
Yeah.
Sorted list, comma, then some
Function.
key equal to some function.
Hmm.
So then what you do is sort the key in increasing order of.
Yeah.
Sort the list in increasing order of the key. So I was wondering if there's something like max
Yep.
list, comma, key equal to something.
Yeah, but I think you can use this idea that you can define this. You can sort, and then you can give as that compare function. You can say f of x less than f of y.
No, that is more complicated because then you need to create the compare function. You can just give a key which is a floating point number or an integer.
Yeah, but I'm saying in general, if you want to compute the minimum argmax of f of x or argmin of f of x over a list, then you would have to use that in the compare function. That's how you would normally do.
Where they have written min point equals to p.
Yeah.
Can we write min point dot x, comma min point dot y equals to p dot x, comma p dot y?
That's right. You can do that. Now the question is, it's again the question is, what does return give you, right? So if you are returning that, you are not returning technically a point. You are returning a pair of values, right? You are returning an xy coordinate, which is similar to what this get point returns. So this is not. So what you get back will have xy as a thing. So right now, if I do this, I get back some strange thing, right? So by the way, Amritanshu, your exec file.
Yeah.
Doesn't work in Python 3.
Oh.
So I'm stuck with this thing again. Okay, so if I say,
We don't want you to do that.
right, so if I say p dot nearest point, okay, then it gives me back something which is a point, so I can't do anything. But I can now apply that get point to get its coordinates. So that's the idea.
There's a min with keys also. You
Oh.
can say min iterable comma key.
Okay.
So you can just say min.
Okay, so then you can do that.
Your code becomes very short.
Right? So this is the way it is set up now, it returns a point to you, and then you have to apply further functions to get its coordinates. Whereas what you would do would say, the way you were saying it, if I say p dot nearest point, I'll directly get 4 comma 5, but then I cannot apply any function to it because it's now a pair of values and not a point. So it just depends on, it's more a question of what you want. So when I say nearest point, it makes sense to return the point. So then you can do whatever you want with it. Okay. So now I am at a point where I am racked by self-doubt. Okay, so I said last time that you cannot change self. Okay, so this was a question which
You can change self dot x and self dot y.
right. So the question somebody asked, you asked, I think, was when I say set point,
Oh, can you say self?
can I just say self equal to a new point with the new value, right? So supposing I right, and I claim this should not work. Right, so if I say this, now if I say p dot set point, okay, that's interesting. Now, what is the difference between what I did now and this is really mysterious. This is really, really mysterious. I'm completely mystified now because this is another copy of the same thing and here it changed. Okay, so I have this. Okay, same thing, except I have not commented out those lines, I just deleted them. This is a different file, almost the same. Okay. So this was the file which I just edited. And this is a different file which I was trying out in the morning, and here it seemed to me that it worked. I'm very puzzled now. Unless this exec has a, this is even more mysterious. So what happened in the morning? Okay, this actually now it's okay. This is what it should do. So I'm happy. But in the morning it seemed to me like it was changing, which was very mysterious.
It doesn't give an error.
No, it doesn't give an error. So this is what so the purpose is I wanted to introduce. So this is what I wanted to just clarify today. So okay. Let me just so I want to talk about just to give a little background on an operational understanding of how Python handles all these things. So what we have seen is that Python doesn't have any declaration, right? So there is no such thing as knowing in advance that x is a float or y is an int or something like that. It only comes as it goes, as you execute it. So the first thing is that there are no declarations. Okay, So declarations in the sense if you have used other languages like C or Java or something, in the beginning you'll say int x, which just announces that the name x is going to be used in this section of code with type int, and it is an error to use it in any other way. Okay, but whenever x comes, it's assumed to be int. Now it's a different question whether you use x without initializing it, what happens and all that, but the fact that it's an int is known to the compiler, and so when it executes the code, it knows it's an int. But in Python, if it sees an x, it doesn't know what it is unless it has a value, right? So the no declarations means that essentially names don't carry value, carry types. Okay, so type is right. So right now I is an int. After a few lines I say I equal to 7.5, I becomes a float. So the name I itself doesn't have a type. The type is what is the value that the name is pointing to, right? So there is a subtle difference. So this is what is known in jargon as dynamic typing. So the type of I is not fixed, it's not static. It depends, it can change. It's not probably a good practice to change it because you only confuse yourself if sometime in your code I is an int and somewhere else it's a float. But the fact is that Python doesn't care. Okay, and the main reason that Python is not that dynamic typing itself is useful, it is that if you don't want to burden the person learning the language or writing the code to keep announcing in advance, because everybody who has programmed in C or Java has come to the situation that suddenly you say, oh, I need now a nested for loop, I need a j, then you have to go back to the top and say int j. Of course now in Java and C++ you can say int j right there, but in C certainly you have to go back and then you say, oh, the k is not found, and then you say you forgot to put k.
No, but in Sage we use dynamic typing all the time.
Yeah.
We don't want to, the same code works whether you have.
No, that's, yeah.
Just implementing different methods for the.
Correct. So there are two aspects to it. So one aspect to it is this kind of polymorphic, that is you can write the same thing and depending on what object you are calling, it will do the appropriate thing for that type of object. So that is a valid use of dynamic typing. But the fact that I equal to 7 can be replaced by I equal to 8.5 is more an accident. It's a byproduct of the feature that you don't have to announce in advance what I is. But at the same time, the thing that is to be, there are two independent statements. The typing is dynamic, but it is strict in the sense that once a value is assigned to a name, you can only do legal things for that value, right? So if I have assigned a float, I can't treat it like a list. If I have assigned a list, I can't treat it like a number, right? So the value determines what is allowed, what is not allowed. Some things are allowed in a kind of generic sense, like what you said. For instance, arithmetic will be terribly painful if you cannot add an int and a float. Every time you have to convert it to the same type, it will be painful. So you can do 7 plus 4.5 and it will kind of, although there is a separate float plus float and there is a separate int plus int, it will allow this to be promoted to float plus float, right? So in some things it will do it, in some things it will not do it. So you have to know sometimes, or you have to look up whether it's allowed or not, but it is, so typing is dynamic but strict. And as Amritanshu said, it could be that in certain situations you can exploit this. So if you have a list of objects, you just want to accumulate them in some way, right? It doesn't matter to you what is in that list. You can just say for I in this list and do it, and whether I is going to become, in one case it might be collecting a set of some type of object, in another case some other type of object. As long as whatever you want to do with I is compatible with both objects, the same code will work. Sort is a bit like that, right? So when you say sort a list, right, sort doesn't really care about whether the list has int or not. It's the same function, and it's able to basically go through, as long as you can compare the values, it's going to sort it. It doesn't care what the specific type of the value is. So it can be exploited positively, but most times it is just a byproduct. You're not expected to kind of be very stingy about, there's no shortage of names, right? So you don't have to say, oh, I don't want to use, let me use X again. There's no problem with using it. Okay, so this is as far as types go. I'll come back maybe to this. We'll have to at some point address this issue about objects and this inheritance probably in the next class, but this is not today's. So I'm not looking at objects per se. But the other issue is to do with names and the association with values, and this is more fundamental, and this is that whole self problem which comes, right? So here is a kind of layman's this is how I like to think of Python's memory, okay, that there are kind of two disjoint buckets or boxes or spaces or whatever, okay. One has names and the other has values, right. So now when I write something like x is equal to 7, okay, what it does is it puts an x here, it puts a 7 here, okay, and then it kind of establishes a link, okay. This is how I like to think about this. So if you look up the value of x, it will follow the link and look up the current value which it is linked to, and everything is linked to only one value or none. Now if it is none and you try to look it up, it's an error, as all of you would have found out in Python. It will say this is not defined, okay. So this is quite easy to understand what happens when x is equal to a value. So a more fundamental question is, what happens when I say the name y is the same value as the name x, is what I intend, okay. Now this is why I call it layman's view. I don't know from a technical point of view what Python would like to say about this, but my version of interpreting this is that it is always this. Okay, so this is a consistent way of thinking about it. Whenever I assign one name to another name, the two are at that point pointing to the same value. Okay. Now, if I say assign x a new value, okay, now this is where things start becoming kind of different for different types. So Python has in its documentation, okay, it has what it calls mutable values and immutable values. So a mutable value is one which can be updated in the place where it is now. That is, I can change, I can cross out that 7 and make it a 9, and x and y will continue to point to it. An immutable value is one which cannot be changed where it is. If you create a new value, you have to create a new object with that value and make a new link, cancel this link and make, and that's what happens with numbers. Okay, so numbers are immutable. So what this will end up doing, so maybe I should use my color. So if I say x is equal to x plus 2, okay, what this will end up doing is it will create a new value 9, cancel this, okay, and establish a new link like this. The net result is what you intuitively expect, which is that y had copied the value of x, and any update to x doesn't affect y, any update to y doesn't affect x. Okay, but actually it is not copied. It only gets separated if you update through one name. Okay, so there is this code which I wrote there, which says x is y. So I don't know if I should.
But still you say that y is now, say 9?
Yeah, so in this case y remains 7. Okay, that's because integers cannot be updated in place because they are immutable. So when I update the value of x, I effectively create a new value to which x points, but that doesn't affect what y points to. Y continues. See, I am not destroying that object. The assignment to x says henceforth make x point to something else. It doesn't say throw away what I had before. Now it could be that nothing is, supposing I had not said y equal to x, right? Then what happens is that 7 is now languishing in my memory with nothing pointing to it. Right? This is a familiar problem to people who use dynamic malloc in C and all that. Right? This is what is called a memory leak. Right? You've asked for some space, right? And then you changed your mind and moved somewhere else, but you did not explicitly release that space. So that space is being blocked by the value 7, but I have no way to get to that 7, because if I say y equal to 7, is going to create another 7. So there is no such thing, as the same 7. Okay, right? So so that is okay. So this, as I said, you have to take this layman's picture with a pinch of salt, because Python sometimes does funny things. But technically, you should think of each assignment that you make to an expression as creating a new value, and each assignment that you make to another name as creating a link. And therefore, if you first create a link and then update one of them, the new value gets created. And so even if I had said x equal to x plus 0, I claim this should not work.
So if you say x equal to x plus 0, it will create another 7.
This is how I understand it. Okay, but it may or may not be true.
Tested by
Yeah, but it
saying
probably is not. It's not true. So this is why I said this. So if I say x equal to 7, y is equal to x, y is x, it says true. I say x equal to x plus 2, y is x, then it's certainly false. Okay, but now if I say x equal to 7, y is equal to 7, is xy? Right? So Python is very strange, okay, about these things.
So
Okay, and I'm not even sure that this behavior is consistent between versions of Python. Okay, but the good news is that this confusion does not bother you if the two values are the same. Right? The distinction between what is the value of x and what is the value of y is important only if one has been updated to a value different from y, and then it surely changes. Right? So same way, if I say x equal to x plus 0.
But if you say x is the empty list and y
Yeah, so that is a completely different thing, because lists are mutable, so that's a different object, right? So this is something I cannot explain in this. So this is like whatever, it's like quantum gravity. Okay, so I can't explain this. It's not yet in my standard model of Python memory. Okay, so but this is as far as I can explain.
kind of bizarre behavior.
Yeah, so it's kind of bizarre behavior.
So that means like both the values are at same address.
Yeah, so if it says is, they're actually physically pointing to the same value in memory. If I say equal to, then in some way Python is able to compare those two values and declare they are equal. So obviously if is true, equal must be true, because it's the same thing. But equal can be true without is being true. Okay, so as Amritanshu said, for instance, if you go to lists, if I say L is equal to 1, 2, 3 and M is equal to 1, 2, 3, this is false. Okay, they are two different lists. So this is why, if you say L is equal to 7, M is equal to 7, they are the same thing. So I don't.
Does that mean that L and M are pointing to the same 7?
Yeah, so it seems to be, and this is something which.
It knows that we've defined something to be point to 7, and then it's making this new thing also point to that same location.
Yeah, and it used to be that I could. So anyway, so you can see that for lists that is and equal to are not the same.
Yeah, so when you create the object, create a memory.
Yes.
So,
Right. So we'll come back to the self problem in a minute. Explain in terms of this. Okay. But so is this much clear? Right. So it should. Okay. So basically, I claim that even if I say x equal to x plus 0, or if I say x equal to 7, y equal to 7, is should not be true. At least by my understanding. But for some bizarre reason, it is true. But that confusion only matters if they are being updated to different values. So long as x is equal to y and y is updated to the same value, x is also the same value, I can't operationally in my program, it doesn't bother me. But if y changes and x changes as a side effect of that, then it bothers me. But that won't happen, right? So for sure, different values are not the same. So whether or not multiple copies of the same value are kept separate or not is a thing which I believe should not be done. Maybe it's some optimization which Python does.
This memory leak
Yeah.
issue, right?
Yeah, so coming back to this memory leak issue, the way that Python and Java and other programming languages deal with it, modern programming languages deal with it, is that expecting the programmer to figure this out is too complicated. So it basically runs a background thing which clears up this memory. So what it does is it knows what names are currently defined, right? So it's called mark and sweep. You go through all the names currently defined and you mark all the memory it points to. Anything which is not marked is garbage. So you go back a second time through the values, and anything which is not marked you say is free. Right? So this is a background process which is called garbage collection, which happens in Java, which happens in Python. And it's good news from the point of view of not having to worry about whether memory is getting wasted or not, because every time you copy, move your thing from here to there, a large chunk of memory could be potentially blocked. So that doesn't bother you. But the thing is that this, because it runs in parallel, this garbage collector runs in parallel, it obviously has some impact on the speed of your code. So it's a little less predictable in Java or Python or these languages how much time a piece of code takes to run. The variation is more, because it kind of depends on whether during that process garbage collection interacted with it, or it managed to come between two garbage collection steps. So it's a kind of, there are background things running other than your code which can affect the speed of your code. Right? So, but that is something you have no control over. But the good news is that the more serious problem is that memory gets used up. Older, it doesn't happen nowadays with browsers, but it used to be very common 4 or 5 years ago that if you left your laptop running, if you did not shut down your browser and restart it, it will just get slower and slower and slower, because these large pieces of code, typically they would be using some storage to remember, cache, URL, this, that, and somewhere somebody would have forgotten to free the space. So as the program runs longer and longer, though it's not doing anything more at that point than it was doing yesterday, the accumulated history is eating up your system in memory. Right? So you have to shut it down and clear that whole thing out and start. So this doesn't happen so much, but it is a very serious problem. And the reason why it's called a memory leak is because if you think of memory as a tank of water, it's a resource. It's like somebody has left a tap open and your memory is leaking out. So it's the other way. It's like somebody is putting bricks into the tank and preventing water, but it's for historical reasons called a memory leak. Okay. So this is immutable. So what else is immutable? So numbers are immutable, that is int and float. So are true and false, which are not so important because you're not going to do much to them. Strings are immutable. Okay, so what this means is that I cannot do a list like update. I cannot say s is equal to hello. So now I know that s4 is equal to single quote, double quote. Python usually reports it as single quote. So of course this is another minor kind of confusion in Python. There is no such, so in many languages like Java, C and all that, there is a unit called a character, and then a string is a list of this unit. Right? So the element, so in a list, if I have the list 1, 2, 3, 4, the first position is not the list 1, it is the value 1. Right? So there is a kind of level difference between what is in the list and the list itself. So you would expect the same thing, that if I have a sequence of characters, that S4 is one of those characters, it has a different status, but no. A string is a collection of strings in some sense. So S4 is also a string. Right? So this is a minor kind of, so there is no unit of single character defined in Python. Single character is a character string or it's a length one. But anyway, the point is that I have this, but I cannot say, I cannot try this kind of thing. So this is not equal to, S4 is, but I cannot try to assign it to something else. Yeah. Let's say whatever. Okay, if I wanted to try and make this, okay, this won't work. Right? So I'll have to create a new string. So I'll have to do something like s is equal to s 0 to 4 plus something like this. Right? Whereas if it were a list, I could do that. I could take the fourth element and change it, and it would work. Right? So that is the immutable versus mutable. So strings are immutable. So are those things which I mentioned. Tuples, which are like lists with a round bracket, okay, which are useful for swapping or for simultaneously assigning and things like that. But these are, you cannot take a tuple and change the second coordinate. You have to construct a new tuple. Okay. So on the other hand, what is mutable? From what we have seen, lists are mutable. Okay. Okay. Dictionaries are mutable. We haven't done much with dictionaries except I made a brief introduction to dictionaries. And in general, objects defined via classes, these are mutable, as we have seen, right? You can change the value of p dot x, p dot y, and p doesn't necessarily change.
Is it possible to define an immutable object?
I don't know. I'm not sure. If it is.
Why would you want it?
Well, you might want to only to prevent somebody from changing it. Like you
Then
want.
implement an equal.
Yeah, no, but if you just want to make sure that nobody, like for example, math.py is an example, right? So I would not like people to, I don't know if you, can you do it?
But you always change it using, you shouldn't use the hidden things, right? So change it using a
How do I say math.py? I always do this.
Math dot with lowercase math should be okay.
See, this is something you don't really want.
Oh,
But you can do it.
you're the Iowa.
Yeah, exactly. If you are in Iowa, or was it Iowa? I don't know. One of those,
They wanted.
some Midwestern place. But anyway, right? So this is the danger. So you would like sometimes to say that this is something which you should not change, right? But I don't think Python has any mechanism to enforce that. Okay. So the distinction now for mutable in that picture that I have. So the assignment works exactly the same. So if I say now okay, so I have L1 and then I have 1, 2, 3. Okay, so this is my first assignment statement. And then just for uniformity, everything works the same way. But because it is mutable, if I do something to L1 inside, so if I say now L1 2 is equal to 4, for instance, okay, update position 2 to 4, then what happens is that this will become a 4, but it will happen in place, that is, it won't create a fresh object. So you can update a part of it, okay. Whereas if I did it the way I had updated the string, if I say L1 is L1 0 to 1, means 0, 1 plus a new value, okay, this will actually create like that. Okay, so just for future reference. Right. So the blue update was in place and the red update creates a new object, right?
What if I make the list with by assigning the name and the student names? It's a list of names.
Like what?
Like say I have a list. I define a list. It's x, x, y. Where I define it. So
So you're saying that what happens if I do L is equal to like this, right? Good question. So test of the standard model. Okay, now so if x and y are so this is how I would picture it. Okay, so first of all, let's assume that x and y are pointing to, let's just say some v and w, okay, some values. So the correct way actually to think of L as a mutable thing oops. Is to draw a picture like this. Okay, so this is pointing to this, and then it's like saying L0 equal to x, right? Putting an x there. So it's like you have this, you have this, and you have this, right? So now it depends on what x is. So if x is immutable, then if you change x, the value in L will not change, or if you change the value in L, the value of L. But if x is itself a list, then it will change, right? So it depends on whether V and W are mutable or not, as to whether an update to V or W will also simultaneously update the copy which L is. So when you assign it, it's just a shortcut. It's saying make L0 point to x, point same value as x, make L1 point to the same value as x. Okay, that kind of thing, right? So this, yeah, I mean, this is something you can probably check. So supposing x is 7, y is 8, L is x, x, y. Okay, but now obviously if I say x is equal to 9, I do not expect L to change, right? Because it was an immutable thing. So now that V has become some V prime. Okay,
And if you say
but
L0 equal to 9,
I mean, you say L0 equal to 9, it's fine, right? I'll get 978.
So the thing is now there is still something pointing to 7, and that is the 0th
Yeah.
position of L.
Yeah, so that old 7 is still being pointed to,
Yeah.
correct? And now in fact you're still being pointed to because the 1th position is pointing to, but it's not again, it's not shared there, right? Because I made L0 9, but L1 did not change, because they are both two different things pointing to the thing.
Now,
But
if you change x, then L will not.
x will not, L will not change. X equal to 10, L will not change. But if I go back and say x is 0, 1, y is 2, 3, L is x, x, y. Okay, so now L is this list. Now if I say x0 is equal to 12,
Then it will.
so x is this, now it has changed in L also, in both places. Because all three are pointing to the same mutable value, and in that mutable value I have made a change, right? So there has been no copying, right? So it depends on not what the value is. So it up to that level this picture works, right? So the only thing is for mutable, therefore you should have this extra level of thing. It's the mutable thing is pointing to the outer container in some sense, and then the contents of the container are pointing to the components, which may be mutable, immutable. So you can change what they are pointing to without changing the container. But recursively they are pointing also to either containers or to values. So depending on whether they are pointing to containers or to immutable values, when they change, whether you copy the change or you don't copy the change is okay. So this is some. So does this clarify a little bit as to why, for instance, that, I mean, I showed you that strange behavior with that 8 by 8 matrix and all that. So if you're not careful, basically if you make two copies, you take the same list and put it in two different places in a square matrix or rectangular matrix. If you copy the same row twice and it's the same object, then updating one row will update the other row also. So you should make sure that you are doing. So this list iteration, this for I thing, that usually creates a fresh object everywhere, but this star does not. So use star with utmost caution, because usually it does something strange, right? So now one place where this is very important is in,
So when you use star, all the positions of the list are pointing to the same thing.
yeah, and it's very strange because it is more peculiar than just pointing to the same thing. Because there, if I change the 0, it kind of made it into a 1 everywhere, which I don't understand that example very well. See, because if I say, okay, so let's do a simpler version, right? So supposing I say, right. So then what I would expect is that first of all L creates at the outer level something with two objects, okay, and then these in turn point to some inner level things, the same inner level thing, okay, which again has two objects, and now at least initially these in turn point to the same, and this is what is peculiar to me, the same immutable 0, right. So this is my from my explanation, this is how it should look, right. But this explanation obviously doesn't work, because if I change that immutable 0 to 1, it should not affect the other copy.
So if you change the 1, like the top,
So now I see what's happening. Okay, so now supposing I change this, supposing now through some path, so supposing I go through this path, right. So supposing I say, you see this L, no, not a good color. So supposing I say L 0 0 is equal to 1, right. So then what will happen is that this will now point somewhere else to a 1, okay, and this will go. But unfortunately,
That is a copy.
this is going through the same route, right. This implies that L 1
It's not a copy. It is
0
that, yeah.
is the same.
instead of 0, if we had
Yeah, so it's not as though that 0 is the thing, that 0 is being shared, so the pointer to 0 is being shared. So if the pointer to 0 goes to 1, then all the things pointing to that will also point to 1. So it's not, so it doesn't affect this guy, right. So this thing remains, L 0 1 is unchanged. Okay, so the fact that 0 is immutable makes the fact that this making 1 point to from 0 to 1 doesn't change the other guy's copy, right. But this links to links says that through this chain the value that you reach is the same as the value that you reach from the other chain, right.
and if instead of 0, if you had the mutable object, then it will change everything.
Yes, but that is always so if you're dealing with mutable objects, this thing is more believable or less surprising. But we're dealing with immutable objects as the bottom. Somehow when this happens, it's a little bit harder to. Okay, so this clarifies hopefully that thing. Okay, now the place where and this is where I'll. So if you say now def right, and then you say call it as f of x comma y, okay, then we know that this associates these values with those arguments, right. So x is associated with a and y is associated with b, okay. So this is as though it's you should think of it as starting by having this two assignments, The name A is the same as the name X, the name B. So therefore, now if the names X and Y are pointing to immutable values, and if A and B change them inside, they will have no effect in the code where you called it. On the other hand, if X and Y are lists or something, and if you update A and B in place, then it will happen in X also. Right? So I am saying that if, okay, so I will write it and then I will, if X, Y are pointing to immutable values, changes in F have no effect. Right? But if they are mutable, F can update X, Y. Okay? So, for instance, I mean, if I write something like so there is a list function called extend, right, which takes two lists and it does L1 plus L2 but doesn't change the list. It attaches L2 to L1. So if I write, okay, and I say return, I don't even have to use return, that's the point. If I just say then within this function L1 is extending L2. But now if I start my code with some x is equal to 1 2, y is equal to 3 4, and I say my extend xy. Okay, after this I will find that x is 1 2 3 4. Because in the when I assign L1 equal to x and L2 equal to y, they are pointing to the same object. Now the extending of L1 happens in place. It's a mutable object, right? So this is the thing. So I have x, y, 1 2 3 4. Right? So this is my initial picture, and now I call this function, and so then I have L1, L2, and as I said, it's like an assignment. So you should just think of as L1 equal to x, L2 equal to y. Okay, and then this L1 dot extend, basically what it does is it makes this 3 4, but it's mutable, so it happens in place. So it happens back in the original thing also. Okay, whereas conversely, if I did something immutable, I said def f a b, and I say a is equal to a plus b. Okay, and now if I say as x is 7, y is equal to 9, f x y. Okay, now x doesn't get updated 16, because what happens here is that I have x, y, 7, 9, a, b. Right. So this, but now this update will create a new copy. So x is unchanged. Right. So the last point is that but, and this is that whole self issue. So you can change the contents but not what it points to. Right? So if I tried this, instead of L1 dot extend L2 I said L1 plus L2, then what this is doing, if I now call f of xy, what this is doing now is so say as usual that 1, 2, 3, 4, same thing. Right. So initially it's like this, okay, but now this statement is actually creating a new list, because this assignment actually destroys this link and creates a new thing here, which is of the home 1, 2, 3, 4. So now henceforth in my code L1 points to 1, 2, 3, 4, but L1 is not the same as what x was pointing to. So when I go back, it restores the x to whatever value it was. I mean, because x has not been updated by this, right? So this is the, so this is why if you say, if when I say p dot get point or p dot set point, it is like saying self equal to p. Then if I say self is some other point, it's like making self point somewhere else, which is not where p is pointing. I can do whatever I want with self after that, but it's not updating p, because p is continuing to point to the whatever object it was pointing to when I call self, right? So self is an internal, it's like an implicit internal argument, which is explicit in the function definition. It's implicit when I call it because it's called p dot get point, but it's like saying get point p comma something or set point p comma something. So p is mapped to self. So self and p are pointing to the same thing. Now if I go around changing self equal to something, then in p nothing happens, because p continues to point to whatever it was pointing to. So it's exactly the same as what happens in the list. X continues to point to the old list, and whatever L1 is doing is a new list. Right? So you can do a lot of manipulation with self, you can do various things with it, but it will not help you update the object. Okay?
So you're saying this is inside a function you cannot do this? Or?
Yeah, I mean anywhere I'm saying that inside, I mean otherwise it wouldn't matter, right? Because I don't come back. But I'm saying that if I take, it's the same principle, right? If I assign two mutable objects, two names to the same mutable object, and I change what one is pointing to, it doesn't affect the other, which is pretty obvious. But it's more insidious in a function because it's implicit that when I call a function, the argument is pointing to the same in the function, the whatever the virtual parameter or whatever is pointing to the same as a concrete argument. And then if I make a mistake in the code of the function where I accidentally create a new object for that parameter instead of keeping it pointing to the same object, then if I believe that the function is updating the value, it's not, because after that the values have diverged. This no longer, so it might even be part way. I might do 2-3 things which change L1 correctly, and then I might make a last step which creates a new L1. So x may be partly updated and partly not updated.
But in the init, if you redefine self, then your whole class is
Yeah.
gone. I mean, it's
Yeah, so if you're,
with it
yeah, because your init is going to return, I mean self,
selfless.
yeah, so you should, so therefore the moral of the story is don't ever directly try to assign anything to self. You can apply functions to self which are defined in the class, or you can update the attribute self.x, self.y, but don't try self equal to anywhere, because that is dangerous at worst and useless at best. I mean, right?
So I'm still very confused by your statement. You say you can change the contents of the mutable object, but not what it.
Yeah, so what I'm saying is that this, I can make this change, but by moving this I can't make x point here. That's what I mean.
But you can make L1 point to a different.
Yeah, but I'm saying that through a function. I'm saying, I mean this is implicitly is through this mechanism. I
So
mean,
if I were, suppose in the main program, if I just said L1 equals 1, 2, L2 equals 3, 4, and L1 equals L1 plus L2.
that's perfectly okay. And that the confusion is in this is in the context. I mean, I should not. I agree that this statement is.
Redefining the name L1 when you say L1 equals L2 plus L1 plus L2. The name L1 is being redefined.
Right.
Being made.
So what I mean is via this process of calling a function and coming back, you can't change what it's pointing to. So the function cannot make it point to a new object. The function can only update the object that you give it. Right? So at best it will leave it untouched. Otherwise it will update it if you really want to. But worst cases you could update it partly. I could do 2 steps with L1 which update it. So x gets changed, and then the third step by accident I do something wrong and I create a new object. After that the future changes are not reflected in x. So x is neither what it was to begin with nor what you think it is after the change. So you have to be a little bit careful when you are passing mutable things to functions and back. So lists have all these functions like append, extend, these kind of things which are designed to not change the object as opposed to anything. So the one thing which the last thing I should probably mention is that, so what happens in lists in particular, okay, so changing a position, okay, this is in place obviously, okay. Changing a slice is also in place. Okay. So if you know what you are doing,
Well, that's the same as changing each one of those.
yeah, no, but slices can also shrink and contract. They can create more values than you can replace 2 values by 5 values, you can replace 5 values by 2 values, you can delete, you can do all sorts of things, okay. So there is no, the cardinality of the left hand side, right hand side need not match. So if I say this, which is a very peculiar slice, it is the slice starting at the last position which doesn't exist in the list, okay, is equal to some new, this is like L dot this is the same as extending the list. So this is saying take an empty slice, the slice which is at the end of the list, and replace it by some non-empty slice. So in a slice, if you leave out the right hand side, it is the length, right? So this is saying length to length. So length to length is empty slice, but it is a particular empty slice located at just to the right of the list. And so you can, in general, you can do that. You can say 1 1 and expand it. It will insert it between 1 and 2.
Yeah, I think I just so can I create a slice? I mean, I assign it as some another list. I assign this slice to another list. Then I will say
No, so right. So now I can say L1. See, L1 to 2 is what the number 1, right? So I can now assign this the list 7, okay, and then I will get this. But I can also assign it a bigger list.
so you said this slicing creates a new.
No, slicing does not create. That's what I'm trying to point out. Slicing does not create. Plus creates a new thing. If I say L equal to L plus something, it creates a new thing. So slicing is a way to get a copy of a list. But updating a slice, when you put the slice on the left hand side, that doesn't create a new thing, right? So if I want to make a fresh copy of a list, I can take the full slice and assign it to a new name. So I say L1 equal to L2 square bracket colon, that will create a fresh copy. But if I say L2 something colon something equal to, is updating in place, and this cardinality can, so now I can do similarly, I can take 1 to 3 and I can say make it empty, then it contracts. Okay, so the slice update need not match left hand side, right hand side cardinality, right? But slice updates are in place, and then of course all the intentionally designed functions like L dot append. So append appends one value, and extend extends it by list, right? So both of these are in place. Whereas if you do this, anytime you use this equal to with a name on the left hand side, it creates a new object. Okay, so if the slice is on the left, it's like updating part of the object in place. So it's as much in place as updating position I, right? So that's the right. Okay, so I'll stop here.